Okay, so in this question, we're looking at finding the domain of the inverse of given functions. So remember, like in the other video, to find the domain of an inverse function, all we really have to do is find the range of these functions. And if we find the range of these functions, those ranges will be the domains of the inverse functions. Because remember, the domain and range just swap when you have a function compared to its inverse function. So starting with A then. So what is really easiest here is to just sketch out this graph. So if we sketch it out very quickly, we only want the region like positive x. So we're going to get roughly something around here. Oops, that's not the best. Something like that, yeah? And we only want the region where x is more than or equal to 3. So if we imagine 3 is along here somewhere, that will correspond to like this point here roughly. Remember, this is only a very rough sketch. It doesn't have to be exact at all. You just need to know the rough shape of this. So we're only looking for this region beyond, yeah? This region when the x values are bigger than or equal to 3. And so if you think about the y values are all going to be smaller than this y value here, yeah? And it's never going to reach this asymptote here. So basically we're looking for this range of y values from 0 up to whatever y value this is. So to figure out what that point is, we can just plug 3 into our equation. So f of 3 will be 4 over 3 minus 1, which is 4 over 2, which is 2. The y value there is 2. And that means that the range of this function will be from 2 to 0. Yeah. The only outputs will be between 0 and 2. And so for our inverse function, the domain of the inverse function will be between 0 and 2. And it'll be less than or equal to 2 because this was a more than or equal to sign. And then we should also say that x is any real value. And that's it. There's our answer. All right, so moving on to B. This time we have x squared minus 5, and x is more than 6. Okay, so we sketched this one out. This one's quite easy to sketch because it's just an x squared, but minus 5, so we shift it down by 5. So it comes down like that. And x being 6 will be, well, it's kind of a bad drawing. If I just redraw that. If I draw it like that. Oops, that's still quite bad. There we go, like that, yeah. 6 will be over here somewhere. Because remember, these will be like positive 5 and negative 5. So 6 is over here. Corresponds to something here. And so we're looking only for this part of the curve up here, when the x values are more than 6. And so we're looking for which y values are bigger than this one. So we just plug in 6 to here to get 6 squared minus 5, which equals 36 minus 5, or 31. And so the y values will be bigger than 31. So the range of this function is that fx will be more than 31. Which means for our inverse, it's the x, the domain, which will be more than 31. And like always, it can be any real value. And that's it. That's the answer to B. Okay, so moving on to C. C says that fx is minus root x plus 4. So fx negative root of x plus 4. And the domain says that x has to be more than or equal to negative 3. X is more than or equal to negative 3. Okay, so if we sketch this one's a bit weird. So it's a root and it's negative. So this one actually looks something like that. I mean, it would continue all the way, but if we only want it for when x is more than or equal to negative 3, we basically don't want this region here. So we can just get rid of that. So it's this here, kind of carrying on forever, I suppose, would be our curve. So again, we need to find out what this point here is. We need to plug the -3 in. So to do f of -3, we're going to get the negative root of -3 plus 4, which is just the negative root of 1, which is just -1. So this point here is -3 minus 1. And that means that our range here is that the y, the fx, can be anything less than -1. And so for our inverse, we swap that around, and we say that the x, the domain, is less than or equal to, because this is a more than or equal to sign, -1. And x is, like always, any real value. And that's it. That's C done, and that's the whole question done. So thanks for watching, and I'll catch you next time.